postulate. Basically, what the parallel postulate says is through any point P not on line L, there is exactly one line parallel to L. Think about that. Would you agree that if we were going to draw a line through point P, it's not on line L, that there would only be one possible line that we could draw that would be parallel to line L? Okay, so again, another instance where I feel like the postulates are kind of common sense. We accept them as true. There's not a formal proof for them, but we will do a construction and construct the line that's parallel. Okay, so that's basically where we will use this. Oh my goodness, awesome. That can be you one day, that's right. All right, so again, the parallel postulate, we'll come back to it when we do our constructions, and we will be constructing a line parallel to another line through a given point, and there will only be one possible line that you can create. Okay, so this goes back to what we did yesterday. So I'm just going to remind you of this. This is a very simple one, so we really don't need to go through and actually work this out in 2 columns. But if it does say show that the lines are parallel, you are going to write a proof on your homework, and it will be 2 column. Okay, every proof. It said that on the slip. Make sure you read that. All proof should be 2 column. I believe there's one on the homework that says write a paragraph proof, and you're going to say nope. Lashley said all proofs are 2 column. Okay. So look at the problem. They're giving you information about 4 and 8. What kind of angles are 4 and 8? Alternate exterior. So yesterday we had a theorem that said if alternate exterior angles are congruent, then the lines are parallel. This would be a simple 2-step proof. You would write down your given, and then you could write down what you are trying to prove. R is parallel to S. What would be the reason? Very good. The converse of. You're always using converse whenever you are proving lines parallel. Okay, so I'm just quickly writing this down. Take whatever notes you need to on your paper. But number 1 would be your given. 4 is congruent to 8. And then 2 would be the converse of the alternate. I don't have a lot of room here. Exterior angles theorem. So some of them on your homework will be simple 2-step proofs. They give you the information, you conclude the lines are parallel. And then some of them are longer, like the example we did yesterday in our notes. Questions here? Okay. So this is a longer one. I actually want to change this up and do a little bit different example than this one, because look at the 2 angles they give us here. Which 2 angles are they giving us? 3 and 7. What kind of angles are 3 and 7? Alternate interior. And if we're trying to prove that the lines are parallel, what would we need to be true about our alternate interior angles? That they're congruent, right? Well, we did an example just like that yesterday in your notes already. We never did one that turned out to be same side interior or same side exterior. Because what do you want to be true for those angles in order for the lines to be parallel? Supplementary, and that looks a little different. So what I want us to do is I want us to change this up. We are going to, we'll do, yeah, I'm going to make up a problem. We'll use this picture, but I'm going to make up a problem. Okay, so change it on your paper. But I want to make sure I give you some numbers that are going to work nicely, and if I just try to make them up, they won't. So let me give ones that will work nicely. No, because those are going to be, when I plug them in, they're going to be equal, and that means they're not going to add to be 180, right? We need them to be 180. So how about the measure of angle 1 is equal to 9x plus 12. And the measure of angle 4 is equal to 6x plus 18. And x is equal to 10. Okay, so now let's go through and do this proof. So I'm going to come over here to the board. Statements and reasons. Did I give you a chart in your notes or no? Yes? No? Okay, sorry. I think the next page is when we get to the different proofs. Okay, so on this one, let's go ahead. We're going to write down our given. Measure angle 1 equals 9x plus 12. Measure of angle 4 is equal to 6x plus 18, and x is equal to 10. And the reason will be given. Okay, what did we say we needed to do first yesterday after our given? Substitute. So we're going to substitute. So number 2 would be the substitution property of equality. Keep in mind, we only have substitution property of equality. So if you're ever trying to substitute and it's not an equal sign, you've got to use that definition of congruence to change it to equals before you can substitute. If you were trying to change it from congruence to equality, yes. Okay, so number 2, we're going to substitute. So we have measure angle 1 equals 9 times 10 plus 12. And measure angle 4 equals 6 times 10 plus 18. What do we do from here? Combine like terms. And I'm going to write combine like terms this time because I always change what you say, Ridley, to simplify. So I'm going to follow what you like. All right, so let's combine those like terms. And what will I get for the measure of angle 1? 90 plus 12, which is 102. So 102 degrees. And what will I get for the measure of angle 4? 78 degrees. So notice the difference now is they are not equal to each other, right? So this is the step from here on that I wasn't sure you would know what to do since we hadn't really practiced that. So what we want to do is we want to add these, right? And we want to add these. So what we're really doing is we're adding angle 4 to the left, but instead of writing angle 4 over here, we're writing what angle 4 is equal to, which is 78. If we add something to the left and we add something to the right, what is that called? The addition property of equality. But it's going to look a little different because instead of writing measure angle 1 plus measure angle 4 equals 102 plus measure angle 4, we're just going to put plus 78. Because we're really adding angle 4 to the left and adding angle 4 to the right, but we're just using what angle 4 is equal to when we add it to the right. So does it make sense that the angle 4 and the 78, since they're equal, we did add the same value to both sides of the equation? Okay. So number 4 would be the addition property of equality. And if you don't like that, if you look at that and go, I don't know why she didn't just add 4 to both sides first, you could. You could put measure 1 plus 4 equals 102 plus measure angle 4. But then you would have to substitute in for one of those angle 4, 78. So we're just saving a step by saying these are equal up here, so it's the same thing really on both sides. Okay, but if you want that extra step and it makes more sense to you, you're welcome to add in an extra step. What would we need to do from here? Simplify. And so this would be number 5, the measure of angle 1 plus the measure of angle 4 is equal to 180. And where would we need to go next if we're trying to prove the lines are parallel? It's not definition of same side. Okay, so the converse of the same side exterior angles theorem, because it said if they add to be 180, then the lines are parallel. So we could say, go back to your theorem from yesterday. I'm going to go back here on the notes and show you. Maybe. Did I hit too many times? Probably just messed it up. Okay. So look back in your notes. Oh, I did it again. I'm afraid to touch it. Okay. So it's probably going to go too fast here. But yes. So go back to that slide and look at what it said. Converse of the same side interior, exterior is the same. If two coplanar lines are cut by a transversal so that the same side interior angles are supplementary, then the two lines are parallel. So if you know that they're supplementary, then you can say the lines are parallel. Does that make sense? So do we know that they're supplementary? Okay, so now we can say R is, was it R and S? R is parallel to S, and the reason? Converse of. And again, I'm going to stress, the only time you use converse is when your statement is about lines being parallel. If you're trying to prove lines parallel, you use converse of. If you're trying to say angles are congruent, you use the original theorem. So this would be converse of same side exterior angles theorem. It's the one the book leaves out, but then you still have to know it. So I don't know why they left it out of the book. Does that make sense? Okay, I wanted to do one like that because we hadn't done any like that. If I can go quickly back to... So now let's look at ones that are a little different, more like this. And first of all, there's a typo on this one. Because notice it says you're given P is parallel to R, but they didn't mark P parallel to R. What did they do? They marked what they were trying to prove, which we don't know that. So that is wrong. We're trying to get there, right? So, I know. So L is not parallel to M. Mark it so that P is parallel to R, because that's what they're giving us. They rushed this book out years ago when we bought it, and so we haven't adopted a new textbook yet. We're close. We will probably soon, but so there's just lots of mistakes. Okay, I think I can just do it over here. So let's go ahead and you guys have a chart. So start filling in your given. Okay, so first thing we're given is that P is parallel to R. Given. Okay, I'm going to break it up and I want you to stop right there and look at P and R. Is there anything that you could now say just given that P is parallel to R by looking at the picture? So 2 and 3 are alternate exterior angles. So if the lines are parallel, what would that mean about angles 2 and 3? They're congruent. So do we all agree that we could say 2 is congruent to 3? Okay. So number 2, angle 2 is congruent to angle 3. What's our reason? Exactly. It's not converse because they gave us the lines were parallel. We're trying to prove the angles were congruent. So our reason is the name of the angles. Don't make that harder than it is. What angles do you have? You have alternate exterior. So the name of your theorem is alternate exterior angles theorem. Except one of them we learned was a postulate, which was the corresponding angles. And then you'll have to add in the words converse of if your statement is lines being parallel and you're trying to prove that. Okay, so we've got 2 is congruent to 3. Now let's go back and look at what else they gave us. I like to break my given up, though, because sometimes it's helpful to say, okay, they gave me this, what do I now know? They gave me this, what do I now know? So now we have 1's congruent to 3. That was given, right? So my reason for number 3 is given. Okay. Let's hold on with that idea first, really, 1 second. Let's look at what we have here. Stop and look at what you've written down. 2's congruent to 3. 3's congruent to 1. Yes. So number 4, what could our statement be? 1 is congruent to 2. And the reason? Transitive property of congruence. So when you're working through the proof, stop each time and ask yourself, what do I know from this? What do I have so far? What could I say next? Keep asking yourself those questions. Okay, now stop and look at where we are. We're saying 1's congruent to 2, so I'm going to mark my picture. 1 is now congruent to 2. So now, Ridley, what kind of angles are 1 and 2? Corresponding. So yesterday we said if the corresponding angles are congruent, what can we now say? The lines are parallel. And that is what reason? Converse of corresponding angles postulate. Good, Bree. So number 5, we can say L is parallel to M. And the reason? Converse of. True, Miranda. Converse of the corresponding. And I'm going to run out of room, so do not abbreviate, but I just did. Yes, I'm running out of room there. Is it starting to get a little bit easier as you're thinking through this? You like the proofs better than the other problems? Yeah? There are some people that are weird like us. Okay, let's try one more. Is this the last one? Okay, and then we'll look at 3, 4. All right, so given 1's congruent to 4, so let's mark it. And 3 and 4 are supplementary. So it's kind of hard to mark that, but you could just kind of circle those if you want to and say they add to equal 180 is what it's telling you. It didn't really say that. It said they were supplementary, so maybe I shouldn't do that because that might confuse you. Let's say this. Supplementary. Okay, so that's what's given. I'm just kind of marking my picture there. Let's go through our proof. We'll start with statements and reasons. Start with your first given, that angle 1 is congruent to angle 4. Okay, keep in mind what your goal is here. Your goal is to get L parallel to M. That's our goal, right? All right, and right now we only have 1's congruent to 4. So what does that tell us? L and N are parallel. We could say L is parallel to N. I'm going to go ahead and add it to our proof. I don't know if we need it, but does everybody see that if these two angles are congruent, then this line L and this line N must be parallel? Why? Alternate interior angles theorem, and what am I missing? Converse of, because it's proving lines parallel. So, yep. You may end up scratching it out if we don't need it, but we'll leave it there in case we do. So converse of alternate, oops, I started to put exterior. It is not exterior, it is interior. Now, when you're writing a proof, do not just put everything you think of. Make sure that it's needed to get to your goal. So if we don't need it, we'll need to go back and get rid of it. If we need it, we'll leave it there. Okay, so now let's add the next thing we know. 3 and 4 are supplementary. So angle 3 and angle 4 are supplementary. And that was given. So what does that tell us if 3 and 4 are supplementary? Okay, but not yet. But what do we know just using that 3 and 4 are supplementary? What's something we could say? Okay, so 2 things I heard. One was we could say that they add to be 180. If I say they add to be 180, why do I know that? Definition of supplementary. The second thing I heard is that M and N have to be parallel. How do I know M and N are parallel? Okay, the converse of the same side interior angles theorem, because they're supplementary, right? Okay, so I don't know which way to go yet. We're going to have to figure out which one of those ways is the way to go. Do we need to say that M and N are parallel, or do we need to say that they add to B180? So let's see what we're trying to get. We're trying to get, so I'm going to go back and use green, but we can't really mark this, but that's our goal. We're trying to get L to be parallel to M. Okay, so let's look at only those two lines. If I'm looking at only those two lines, what would I need to prove those lines? Okay, what about 2 and 3, Molly? Okay, they are vertical, but that doesn't prove lines parallel. So how could I use that? Okay, hold on just a second. Molly? Okay. So 3 and 4 are supplementary, and 2 and 3 are congruent. How does that get us? Maybe we want 1 and 2 to be what? We want 1 and 2 to be supplementary, right? Does everybody agree that that's our goal? Okay. So let's see if we can brainstorm how we could get 1 and 2 supplementary from what we know. We know these two are supplementary, and 3 and 2 are going to be congruent by vertical. Say it again, Alexis. Okay, so we're going to have to try to prove that, right? Did we use the lines being parallel here at all for any of that? No, so I'm thinking that we don't need to say M is parallel to N. That's not really necessary. Would you agree? What we kept talking about was these are supplementary. That seemed to be what was important. Have we needed L and N to be parallel yet? No, and I don't think that we will. So I'm going to scratch that out. I don't think we need that in our proof. Even though it was something we could conclude, it wasn't really necessary for our goal. Okay, so we have 3 and 4 are supplementary, and then I heard we need to bring in the fact that we have vertical angles, right? And that 2 is congruent to 3. So let's go and do that. So number 4, angle 2 is congruent to angle 3. What's the reason we know that again? Vertical angle theorem. Converses are only for the 5 kinds of angles and only if you're proving lines parallel. We're talking about angles being congruent. Okay? Vertical angle theorem. Okay. So what can we do from there? What would be a reason that says we can jump straight to 1 and 2 are supplementary? I think you're thinking that it must be true, but our reasons have to be definitions, theorems, postulates, or properties. And I don't think we have a property yet that would allow us to go straight from only having these things here to 1 and 2. Okay, we can use substitution, but only if it's of equality. So we will need to write some things down in terms of equal signs if we choose to use substitution property, and we could. So if we do that, though, we're going to need to go back and write an equation here and change this to an equal sign. Does everybody understand what Katrina's saying? So she said, could we substitute, and you're saying, could we substitute what for what? Okay, so we have 2 is the same as 3, and so instead of having 3 and 4 supplementary, we could say 2 and 4 are supplementary. Okay, and then since 1 and 4 are the same, we could say 4 and 2 are supplementary. Or not, sorry, 1 and 2 are supplementary. And that would give us what our goal is. Okay, but to do substitution, we're going to have to change everything to equal signs. So here we go. So number 5. I think we have an easier way we could do it, but I'm going to do what you guys are thinking first, and then I'm going to come back and show you. No, come on. Let's write this down. This could be. Come on. Stop complaining. Here we go. Number 4. Measure of angle 2 should now equal the measure of angle 3. This is good practice too, because you have to be able to change things to equality. Why is 2 equal to 3? Definition of congruence. Do you want to go ahead at the same time, since we're using the same reason, and go ahead and change angle 1 and angle 4 to equality? Okay, so measure of angle 1 is equal to the measure of angle 4. Please stop me if I lose you anywhere. We just did it all in 5 because it's the same reason. Is that okay? Okay. Then we need the equation from statement 3, because right now we just have that 3 and 2 are supplementary. So what do we need to write down? Exactly. We need to use, what did you use there, Katrina? Exactly. So number 6 needs to be that the measure of angle 3 plus the measure of angle 4 is equal to 180. And that was the definition of supplementary. Okay, so now we're ready to do what? Substitution. So we're going to substitute in for angle 3 what angle? What's going in for angle 3? Angle 2, right? Because that's what 3 is equal to. So we're going to have measure angle 2 plus what's going in for 4? 1. And that is now equal to 180. And the reason was? Substitution property of equality. And then number 8, if 1 plus 2 adds to be 180, then L is parallel to M. L is parallel to M, and that would be the converse of what? Exactly. See, it wasn't so bad. I'm going to abbreviate. Do not abbreviate on your homework. Same side, interior, angles, theorem. The only problem with that is transitive property is of equality or of congruence, and those are not equations or equal or congruent statements. Does that make sense? There is a theorem we haven't learned yet that says if 2 lines are parallel to the same line, then they are parallel to each other. And we could have used that had we learned that, but we haven't learned that yet. It's not in our notes yet. So, no. I don't think so. I'll look. I don't think so, though. Okay, but the great thing about doing it this way is it made us think about how would I do it if I didn't know something. And you are going to have problems where you have to change from congruence to equality and use substitution. So I think it's a good process that we did it that way. Okay? All right, look at your 3-4. Okay, first thing in 3-4, it's just a couple definitions, and these things you're going to use a lot in problems that are not proofs, okay? So the first one is the perpendicular bisector. We actually already did this construction. I just didn't call it a perpendicular bisector. When we took a line segment and we bisected it, remember when we did that? When we constructed the bisector of a line segment, when we did that construction, we just put our compass on one end point and made a big arc, and then put it on the other end point and made a big arc, and we drew the line that went through it. That line bisected the segment, but it was also perpendicular to the segment. We just didn't call it a perpendicular bisector. So when we review this construction with this homework, you already know how to do it. Okay? It is not really a new construction. It is a perpendicular bisector because it's not going through the line at the midpoint slanted. This would be a bisector, but it's not a perpendicular bisector because it's not straight up and down. What does it have to form if it's perpendicular? A right angle. So if it's a perpendicular bisector, it's not only going to split it into two congruent parts, but it's also going to form 4 right angles. Does that make sense? All right. So the definition of a perpendicular bisector is simply a segment is simply a line that is perpendicular at the segment's midpoint. And I'm going to warn you, that part's important for your homework. Some of your homework problems are going to get a little harder. So a perpendicular bisector is a line that is perpendicular at the segment's midpoint. So if you need to know exactly where to draw that line, you're going to need to know where the midpoint is, which you've learned your midpoint formula, right? Okay, so don't forget about that. All right, the next one is kind of common sense as well. If I'm standing right here and I want to walk to that wall, and I want to walk the shortest distance possible, do I walk straight perpendicular to the wall, or do I walk diagonally to the wall? Perpendicular, right? Straight, so that if I took my path, it would make a right angle with this wall, right? Agreed? Okay, so that's what they're telling you here. The shortest segment from a point, I would have been the point, to a line, the wall would have been the line, is always the perpendicular line to it. Always. So in other words, if I have a line here and I have a point here and I draw these 3 line segments, AB, AC, AD, which one of those 3 line segments will be the shortest distance from point A to the line? AC. So you'll have some simple questions like that, where all they do is say, name the shortest segment. You look at the picture, you look for the segment that's perpendicular to the line, that's the one that's the shortest distance. Okay? Say it again. Yes. So the answer would be AC with a line above it, because you're naming the segment. Or a line if it's a line that goes on with arrows. All right? Or a ray if it's a ray. So here's some simple questions for the homework. We're going to get back into inequalities in part B, like you talked about in Algebra 1. So, but part A is super simple. Name the shortest segment from point A to line BC. So what's the shortest segment? AP. The one that's perpendicular. Okay? AP. Does everybody agree that's the shortest? Okay. Definition says it has to be perpendicular to be the shortest. Otherwise, if it's slanted, think about it in terms of a right triangle. This is your hypotenuse, right? It's always the longest side. This is a right angle, so this is a right angle. That makes this your hypotenuse. It's always the longest side. Okay? All right, so part B. Write and solve an inequality for x. So go back to what we just said. Look at your expressions here. You've got x minus 8, and you've got this number 12. What's the relationship if this is the shortest distance between these two expressions? Exactly. X minus 8, we're trying to write an inequality, which is a less than or a greater than or a less than or equal to or a greater than or equal to. So x minus 8 is what compared to 12? Greater. So x minus 8 is greater than 12. It says write it, so I'll be grading that you actually wrote the inequality. And then solve for x. So then you'll write me your answer for the value of x. So how do I solve that for x? Add 8 to both sides. Make sure that you don't change your inequality to an equation. It's still an inequality. So x is going to be greater than 20. Yes, so good question. If you multiply or divide by a negative, then you have to flip the inequality sign. But only if you multiply or divide by a negative. If you multiply or divide by a positive, it doesn't change it. Good. I'm glad you said that, Edwin. So you should be able to write an inequality and solve an inequality. And it's just simple. The line that's perpendicular is the smallest, okay? The shortest. Those should be really easy questions. Should be. All right, so before we can do the rest of our proofs, we've got to learn some more theorems. And this is where, again, to try to help organize your thoughts, let's make a little chart up here. Yeah, I would write this down. So do you have a big, yeah, there should be a big blank box there, right? Okay, we're going to make a list of the ways to prove lines parallel, and then the ways to prove lines perpendicular. And I don't know if you guys noticed when I passed back your homework, on a lot of people's papers, you just put the word and. I didn't count off for that when you were naming your angles or naming your segments. But you want to get used to using that parallel notation and that perpendicular notation because you're going to see that all over the place. It's not that I'll necessarily count it wrong, but I'm trying to encourage you to use it, okay? So if you looked at your homework, I added that if you use the word and instead, just to try to get you to think to use that. Okay, so right now, we don't have any ways to prove lines perpendicular. We have not learned anything about that. But we have learned 5 ways to prove lines parallel, right? We learned them yesterday. The first way we learned, and all of these start with what phrase? Converse of. So I'm going to be lazy on my notes here and write converse of and then use little ditto marks. You guys are familiar with ditto marks? Okay, it's just a way to say I'm going to copy exactly what I have up above. So same thing as up above. So they're all going to start with converse of, converse of, converse of, converse of. Feel free to write that 5 times if you want. And then let's name the 5 different postulates and theorems we learned. So converse of, corresponding, angles, postulate. It's the only one that was a postulate. The other ones are all theorems. And then we had the converse of, okay, same side, interior, angles, theorem. What else? Converse of, same side, exterior, angles, theorem. Go ahead, Karina. So converse of, the alternate, interior, angles, oops, I spelled interior wrong, interior, theorem. And then the last one, converse of, alternate, exterior, angles, theorem. And I know you may be thinking, oh, good grief, why do we have to write all those down again? Because you will now have a chart of all the ways to prove lines parallel when we add the next couple that we're going to add. Okay, so we're going to have a couple more that we're going to add to our chart. Actually, one more here. I don't think there's another one. Can I steal your notes really fast? Yeah, just one more. This one is down here at the bottom, and the reason that I know it's proving lines parallel is because look where it says conclusion. This is proving lines what? Perpendicular. This one? Perpendicular. We'll come back to those. This one is proving lines parallel. So this is the 6th way we're going to prove lines parallel. We're going to add it here. No, this one's different. So they haven't taught you this yet, or taught you that yet. So here is our next one. If 2 coplanar lines are perpendicular to the same line. So look at the picture. Do you see that R is perpendicular to T? Okay, and do you see that S is perpendicular to T? Okay, so in your proof, you would have to have this listed as one of your statements. R is perpendicular to T, S is perpendicular to T. If 2 lines are perpendicular to the same line, then those 2 lines are not perpendicular, those 2 lines are parallel. And it doesn't have a name. So it's another one of those where you just have to write it out. But the good thing is you can put it in your own words, okay? So, I don't know. So we'll just say if 2 lines If two lines are perpendicular, use your symbol to save time, to the same line, then they are parallel. If two lines are perpendicular to the same line, then they are parallel. And those are your 6 ways to prove lines parallel. Most of them start with converse of. So when you're looking at a proof, you're looking, do you have angles? And if you do, and you're trying to prove lines parallel, converse of. If you're looking at statements about perpendicular, then it's not going to start with converse of, and you're just going to say, if two lines are perpendicular to the same line, they're parallel to each other. Okay? Ways to prove lines perpendicular, there's only going to be 2 ways. No more. 2 ways that we're going to learn. So when you're in a proof and you're trying to prove lines perpendicular, you got a 50-50 shot of getting the answer right, right? So here we go. Number 1 does not have a name. Okay, so here's what it says. If two intersecting lines form a linear pair, so the first thing that you're going to have in your proof is that you have a linear pair. So for example, if this were angle 1 and this were angle 2, we would have to say angle 1 and angle 2 are a linear pair. That would have to be in your proof somewhere. Okay? If they form a linear pair of congruent angles. So the next thing that would have to be in your proof is that angle 1 is congruent to angle 2. If you had both of those things in your proof, they're a linear pair and they're congruent to each other, the only way that's possible is if those angles are what value? If two angles form a straight line and they're congruent, they're 90, which means the lines would end up being perpendicular to each other, right? Okay? So, but you would have to have these 2 things in your proof. It depends. I mean, you could, no, that those 2 things probably, unless they were just given to you, wouldn't be on the same statement in your proof. And then probably angle 1 is congruent to angle 2. But somewhere in your proof, you'd have to have those 2 things before you could conclude L is perpendicular to M, and then this is your reason. Okay, so your reason would be if 2 congruent angles form a linear pair, then the lines are perpendicular. And again, you can state it however makes more sense to you. But if 2 congruent angles form a linear pair, so I've got they're congruent and they're a linear pair, then the lines are perpendicular. That's a little faster to say than if 2 intersecting lines form a linear pair of congruent angles and the lines are perpendicular. Are we good? You still have to have those 2 things, linear pair and congruent. You could definitely write it this way using the symbols, just don't abbreviate the words like linear. Okay? Sure. Okay, second way does have a name. It's called the perpendicular transversal theorem. Perpendicular transversal theorem. And again, you can use that perpendicular symbol anywhere that the word perpendicular is. So perpendicular transversal theorem, think about what the name, because it's going to tell you what you have there. In a plane, if a transversal is perpendicular to one of 2 parallel lines. Okay, so in your proof, you're going to have that 2 lines are parallel. Which lines are parallel here? Oops. Sorry, hold on. No. There we go. That's what we did. So N and P are parallel, right? Oh, I did that. Now it's going to mess it up. I'm sorry. Hold on 1 second. Look at the picture. It's marked. Okay, let's try again. Here we go. Quickly. Look at the picture. Which lines are parallel? N and P. So in your, oh my goodness, why won't it let me write? I don't know. I'm going to do it over here. Okay? So this is the perpendicular transversal theorem. Let me redraw my picture. N, P, Q. Okay, so in your proof, you're going to have a pair of parallel lines. N's marked parallel, so in your proof, you would have to have N is parallel to P. Write that down right here under your hypothesis. And you have to have a transversal perpendicular to one of those lines. So which two lines are perpendicular? N and Q. So you would have to have N is perpendicular to Q. These two things would have to be listed in your proof somewhere. If they were, so you have P is parallel to N, Q is perpendicular to N, then that means P is going to be perpendicular to Q. Perpendicular transversal. So you're stating that they're perpendicular. It's kind of like a transitive idea, okay? Yes. Okay, so then you can conclude that, what did I say? P is now perpendicular to Q. Okay? So those are your two ways to prove lines perpendicular. All right, let's practice some proofs. How many proofs are left in your notes? 2? All right, let's see what we can do. So first one, write a 2-column proof. I should have given you, oh, I keep trying to do that. I'm going to come over here. I gave you a statements reasons box, right? Okay. So now you're going to start with your given. First thing you're going to write down is R is parallel to S. Given. Don't forget to label statements and reasons at the top. Already there, perfect. Okay, stop right there. R is parallel to S. We are trying to prove what? R is perpendicular to T. So now when we think about what are my ways to prove, I only have 2 options. I either need to get a linear pair of congruent angles, or I need to get a pair of parallel lines where one of them is perpendicular to the transversal. So look at what we have. We have 1 and 2 congruent. I'm going to go ahead. I can't mark them. Why do I keep trying? 1 and 2 are congruent, so mark those on your picture. I need to redraw this so I can mark it. Okay, so we have 1's congruent to 2. Do those have a relationship, though, of any of our 5 angles? No, 1 and 2 don't, right? So what we have to decide is, do we have a way to either get a linear pair of congruent angles, or do we have a way to prove that 2 lines are parallel and one of them is perpendicular to the transversal? Okay, so 3 and 2 are corresponding. Okay, so Javi thinks we're going to use the first way. Alexis is saying if 2 and 3 are corresponding, then that means because R and S are parallel, that means if these 2 are corresponding, that they're what? They're the same, they're congruent. And if 1 and 2 are congruent, then that means that 1 and 3 are congruent, right? And what kind of angles are 1 and 3? First, though, what kind of angles are they? You're giving me their measurements. What kind of angles are they? You're still talking about their measurements. What kind of angles are they? Linear pair, okay? Name of the angles. What kind of angles are they? Okay, so here we go. We went ahead and used 1 was congruent to 2 pretty quickly, so I'm going to go ahead and just list it in my given. But you can do it as a separate step if you want to. What did we say as soon as we knew that R was parallel to S? That 3 and 2 were corresponding, and because they were corresponding and the lines were parallel, that meant that they were congruent. So angle 3 is congruent to angle 2, and what's the reason? Corresponding angles postulate. Not converse, because we're not proving lines parallel. Okay, and then you said if 3 is congruent to 2, and they told us 1 was congruent to 2, where did you go next in your mind? Okay, so we are going to need to say 1 and 3 are a linear pair, but hold on. The question was, if 3 is congruent to 2 and 1 is congruent to 2, what did we come up with from that? Hold on. Say again what you said, Katrina. No, be careful. 1 is congruent to 3 is what comes next, but perpendicular transversal theorem is a way to prove lines perpendicular, which would mean, hold on, which would mean your statement needs to be about lines being perpendicular if you're using that theorem. Does that make sense? Okay, so Edwin, what did you say the reason was? Not substitution? Transitive. Substitution only works for equality, and we don't have anything about equality here. You are right, girls. Transitive. Property of congruence. Now, Javi said, I think we're using number 1. We just proved that 1 and 3 are congruent, but what are the 2 things you have to have? They need to form a linear pair. Have we stated that they're a linear pair anywhere in the proof? No, but we're going to. So let's do that. Number 4, angles 1 and angle 3 are a linear pair. Now, how did we know they were a linear pair? No, look at the picture. How did you know 1 and 3 were a linear pair? They formed a line. What tells us that if 2 angles form a straight line, they're a linear pair? And there's linear pair theorem actually says if they're a linear pair, then the angles are supplementary. But the definition of linear pair says if 2 angles form a straight line, then they're a linear pair. So this is from the picture, we can use the definition of linear pair. Be careful you don't confuse that with the linear pair theorem. Most students do when they make it, if they're confused. This just simply says I looked at the picture, they're forming a straight line. The linear pair theorem says because they're a linear pair, then they must be supplementary. Okay. We could go there next, but we don't need to go there next for this proof, yes. Because now we have they're a linear pair and they're congruent. And if they're congruent and form a linear pair, then the lines are perpendicular. So R is perpendicular to T. And there is no name for that. You're just going to write it out. If 2 congruent angles form a linear pair, then the lines are perpendicular. Now you're going to have to study the ones that don't have a name because you're not going to remember them for the test if you haven't really studied. There's only 2 up on the board that don't have a name. But you're going to have to study. Vocab is vocabulary only, not postulates or theorems. So those won't ever be, postulates and theorems will never be on a vocab test. You're good. Okay, let's talk about this last one. Okay, write a 2-column proof. Same thing here. I'm just going to erase what I have up here on the board. Look at the picture. What are you trying to prove? Okay, we're trying to prove lines perpendicular. How many options do we have to prove lines perpendicular? 2. It's either the perpendicular transversal theorem, which says you have to have a pair of parallel lines. One of them has to be perpendicular to the transversal. Or we need to get a linear pair of congruent angles. Okay, so let's look at what we have here. EHF, it's already marked, is congruent to come back up. It doesn't like me. I don't know. There we go. So EHF is congruent to HFG, right? Those are marked congruent. Stop right there and just ask yourself. And ignore the things you don't need in the picture. So we've got EH and this little line here forming that angle. And then GF and this little line forming that angle. What kind of angles are those? So this angle and this angle are the angles marked in the picture, right? H and we've got E somewhere up here. And this is F and this is G somewhere down here. What kind of angles are those? So if those alternate interior angles are marked congruent and given to be congruent, what does that mean about these two lines, EH and FG? They're parallel. So we just got ourselves a pair of parallel lines, right? And if we have a pair of parallel lines and one of them's perpendicular, then we can use the perpendicular transversal. So now look at what the second thing they gave you was. FG is perpendicular to GH. FG is one of those parallel lines. And it is perpendicular to, I'm going to move G down here a little bit so I can draw it through there. It is perpendicular to GH. So which of those two does it look like we're going to need to use? The perpendicular transversal. Let's fill it in. So angle EHF is congruent to angle HFG. I'm just writing down the given. I'm going to go ahead and put them both at the same time. FG is perpendicular to GH. Given. The very first thing that we looked at were those congruent angles. Right? And you said they were what kind of angles? Alternate interior. And so then we said because the alternate interior angles are congruent, which lines are parallel? Say it again. Not HG. EH and FG. These are going to be parallel, right? Okay. So EH is going to be parallel to FG. And what was the reason we could say that? Good. Starting with converse of. Converse of the alternate interior angles theorem. Okay, so we have a pair of lines parallel. And in statement number 1, make sure you're following this up here right now because this could be confusing on your own at home. So I'm going to point out one more time how we know what to do. If you have a pair of lines parallel and one of those lines is perpendicular to this transversal GH, which it is a transversal, right? It's intersecting the other two. Then that means, kind of like transitive, these two lines are going to be what? Perpendicular. Okay, it's called the perpendicular transversal. You're proving lines perpendicular. So you can kind of think about it like transversal, or about, like transitive. You're using EH is now going to be perpendicular to GH. And the reason is not transitive, it is that perpendicular transversal theorem. And so this was a really short one, but sometimes it's a little confusing. And that's all they wanted us to prove, right? Okay, so here's the thing. We are not going to have time to get to the constructions, and part of your homework is construction.